240 trees, one simple question: does a taller tree grow more fruit? Plot height against yield, and a cloud appears, noisy but leaning upward. Draw one straight line through that cloud with np.polyfit, and there it is. The whole orchard reduces to a single number, roughly 17 kilograms of extra yield for every added meter of height. That line is today's entire lesson. A scatter shows 240 individual trees. That's honest, but overwhelming, no single takeaway. A fit line compresses the whole cloud into one slope and one intercept, a summary you can quote in a sentence. Today you'll build that line with np.polyfit, read what its slope actually means, and learn the one mistake that turns an honest summary into a dishonest one: fitting too many degrees. Before fitting anything, let's read the raw spread. Height barely moves, 2.3 to 3.8 meters, a range of just over a meter. Yield swings far more, 29 to 86 kilograms. Correlation lands at 0.45, real but far from perfect. Watch point size climb from a near-invisible speck to an overlapping blob. Before it settles somewhere, every tree stays distinct. The entire technique is 3 lines, honestly. Fit returns coefficients, highest power first. For degree 1, that's slope then intercept. Feed those coefficients and any x values into np.polyval to get the line's y values back. No new library, no manual algebra. Numpy solves the least squares line for you in one call. Start with the scatter alone, no line yet. Near 0 alpha the dots vanish, you'd swear the orchard was empty. Push alpha to 1 and overlapping trees fuse into solid blobs, hiding exactly where the data piles up. 0.5 is the honest middle. Each dot stays visible, and overlap reads as a darker patch instead of disappearing. Now the line itself. Degree 1 draws a straight, honest slope through the cloud. Watch what happens as degree climbs toward 9. The curve stops summarizing and starts chasing every last wiggle in the data, arcing up toward a physically impossible 120 kilograms. Settle back at degree 1. And there, one straight line, honestly describing what the trees actually do. Step through the ladder yourself. Degree 1, 3, 6, 9. 1 is a clean straight lean. 3 adds a gentle bend, still plausible. 6 starts to wander between clusters of points. And 9, well, it whips into the sharp, implausible arc you just saw. There's no dial that announces the moment it breaks, only a curve that stops looking like biology and starts looking like arithmetic showing off. Degree 9 looks like a better fit. It bends to hug more points. But its in-sample error barely moves, 8.8 kilograms versus 9.0 for the straight line, while the curve swings up to 123 kilograms, a yield no tree in this orchard ever produced. It memorized noise, not the trend. Degree 1 stays inside the real range and, well, tells the truth.